Vlsi lab. So now we just created the NAND gate schematic in the previous video. So now we are going to create the NAND gate layout. So if you are watching this video for the first time, so for the prerequisite of installation of this software, electric software, all these things, please refer to the first video of this series. And now we have the library. In that we have the inverter and the NAND schematic. Now we are going to construct the layout for this NAND gate. So for that one, go to the so just go to this VLX experiments and right click on it, and on the library right click on it and create new cell, and here select the layout and select NAND. Okay, so select the NAND, whatever the same name here for the schematic, give the same name. Only the layout is also possible directly. So just click on this. Now we have the NAND gate layout here. So for the layout things, we need to follow the same thing. Okay, so we need the 2 PMOS and 2 NMOS. So let's and we need to do the namings for this one. So for a easy purpose, so let's just name these things. So for that one, I'm just going to add some text. So for adding the text, okay, so just go to the MIC annotation text, and this is the source. I'm just going to write this as the source. Okay, so this is the source, this is the gate, and this is the drain, that we can easily refer. This is the source, this is the gate, this is the drain, and this is source, gate, drain. I guess no need to annotate here. You can just annotate on a paper. It's just to draw the layout. So in the layout we need to have the 2 PMOS and 2 NMOS. So let's construct the PMOS first. Okay, so let's construct the NMOS first. NMOS. I need to click here, and for this one we need to have the for the NACT we need to have, and for the NMOS here also we need to have the NACT, and double click on this. The width is 10 and length is 2. We are following this. So here also the width size is 10. We need to make this as 10, and here also X size, you just make this as a 10 so that it matches the width, and align it properly. Okay, so just align it properly. Here also align it properly, and now let's connect from here to here, and let's connect from here to here. Okay, so now just bring it like this. It has the spacing 3, and just once observe this schematic. Is there any possibility we can join the 2 NMOS? So these 2 NMOSs are combined. Okay, so these 2 NMOS are combined. That is this the source, gate, drain, and source, gate, drain. That means we can have the 2 NMOSs combined to form 1 NMOS in a layout. Instead of having the 2 separate NMOS, we can combine this, because here the diffusion, this diffusion is a it is same for both these NMOSs. That's why in the layout also we can make that diffusion, any one, this diffusion or this diffusion, which is common for both this NMOS and as well as the another NMOS. We can make like that. So for that one, so just go to the components and take another NMOS and place it over here and make its length. Okay, so make its width as 10, and just align it properly. Okay, so okay, now it's aligned properly. Now just connect from here to here. Okay, just connected. Now we can see and another one, another NACT. Okay, NACT, we need to have this side. Okay, so we need to have this side. Okay, another NACT, and just connect from here to here. Okay, so just align it and make this as a length as 10. Okay, so make this as a length as 10, and after that align it properly, then connect it. Okay, so then connect this one from here to here. So now we can see we have the one okay, so this is one gate, that means one NMOS, this is the another NMOS, and this is the that uh, okay, let's consider this as the source, gate and drain, and here this diffusion, that is the here in the schematic we can observe, right? So here this diffusion, this is that diffusion, it is connected. That's why we made like this, that is connected. Okay, that's why we are connected like this. So now we need to bring this back to the okay, so just spacing of 3, and here make this back to the spacing of 3, and then just select only this one. Okay, don't select complete things. If you select this complete like this, it is not possible to move, because it will select this also. If we move like this, it will give us the error. So it is not possible to move like that. Only just select this one, so it will select this gate and this one. Now we need to bring it back, like bring nearer to the okay, so okay, just like this, just on a distance basis, we just need to see what is the distance between this. We can see here. Okay, so it is not, it is giving the error, so we need to have this just one step away. So now we can see it is set properly spaced at 3. If I just make come 1 point down, it will give us the error, and even up also it will give us the error. So now this is at the exact position. Now we form the like connected diffusion, 2 NMOS we formed. So this to save the area. You can have the different NMOS and you can connect that using the metal or using any wires or anything you can connect. So but here you can connect using the metal, that also fine, but here we have directly like this. Okay, so now we just rotate this. So now we have this two NMOSes, 2 NMOS we have. Okay, so now we need to form the PMOS. So for PMOS we can see, for the PMOS also we can see here this source and this source that have the common, that means they have the common diffusion, so we can form the connected PMOS. Okay, connected PMOS, or we can make even these drain. Okay, so source gate drain also, this is connected, so we can even make as a common drain diffusion or common source diffusion, anything is fine. So we will similarly make the structure like this for the PMOS also. So for that one, okay, let's so for the PMOS, okay, so I'll just go to the components, and we need to select the length and the width. So okay, so PMOS, and we need to select its length and width, and that is width is 10 and length is 2. So width is 10 and length is 2. Okay, so for the PMOS we need to have, okay, let's just have that here, and for the PMOS we need to have this P act, that we need to place this side, and another P act we need to place above, so here we need to place, and another PMOS, simply just copy this and paste it here. Okay, so just copy this and paste it here, just drag this side and make this size as 10, make this size as 10, and here also make this size as 10. Okay, let's make this size as 10, and this is 10. Now we just need to copy this and just paste this, and okay, so let's have this here, now align all this properly. Okay, so align these things, align all these 4, not 4, align all these 5, and just connect this. Okay, and just we'll connect this, just connect like this. Okay, so this connected. Now bring this to 3, and similarly bring this to 3. Okay, now this side make this to 3, and just select this and bring this nearer to this, and just check. Okay, so it is at the center. So now we even form the PMOS, and Control J, and just place here. Okay, just place it across here. So now, okay, we need to place exactly. Okay, okay, I guess here it can go further. So yes, it can go further, and here we can just, okay, we can have that here, get it done. Okay, all these are proper, right? Yes, yes, it is proper. We just need to have it properly aligned to this. Okay, now we have, now you can check once the DRC if any errors. No, there is no any error. Now we need to have the two things, that is N well, that is for here the P side. Okay, so we can have this with the length of 10, and we just have it here, and even we need to have the P well, that is near the NMOS side, and have its width. Okay, width 10. Okay, so this is for VCC and the ground. So now we have like this. Okay, so now let's just follow the paths like here. Okay, so this is the drain, PMOS 1, PMOS 2, like that we will just annotate, else it will just going to confuse. So just go to the MIC and annotate text, and here we will be having the this is PMOS 1, P1, or okay, so we have this PMOS 1, and here similarly we need to have PMOS 2. Okay, so this is just for our reference, PMOS 2, and here NMOS 1 and NMOS 2, NMOS 1 and NMOS 2. I hope you can see this. Okay, so this is N1 and this is N2. Okay, so this just for our reference. So now in the schematic, we can see the PMOS to source. Okay, so PMOS to source. Okay, we will follow the path like this. Okay, so in the anti-clockwise like this we will follow the path. So here PMOS source and PMOS 1, this is source, these two are connected. So here we make this as the source, PMOS 1 source and P2 source, these two are connected. Okay, so or else we will do one thing, we will just extend this, we'll just extend this to 20 and just have it here. No, we need to extend even more, so just extend this to 30 and just have it here, and we can connect from this one to here, that is the source of one and another one is the source of another, we can see here. So these two source of P1 and P2 are get connected, and these two drain. Okay, so these two drains are connected, so here these two drains are already interconnected, that's fine. So now from that drain we need to connect it to the one of the drain of the NMOS, so this we consider as N1. So N1 drain. Okay, so N1's drain. Okay, so N1's drain, this is connected to N1's drain. So we just have all these things little bit away, and this one is connected to, okay, so this one is connected to N1's drain. Now this one we need to connect here, it will not take, you just need to click here and just come here and click here. Okay, so go to the components, just select metal and select here and select till here and select here and select here. So if any extra part, you can just delete that. So here we can see those extra parts, from here to here you need to connect. So now better you can check the DRC. Okay, so one error is found, like here these distances matters, so separation. So here it is showing the minimum width or height error y-axis. Okay, so width, that means okay, we will decrease its width to 20 and let's see. No, it's not like this. We can have this size to 10 and we can have over here, and we will connect one is this and okay, so now let's check the DRC. No, there is no any error. And another one will connect like this and let's see. Okay, so now go to tools, check. Yeah, now it's possible. You can see, go to tools, DRC, check hierarchy. So it's possible, we can connect like this. Okay, so like this, the main intention is to do with the less resource. Okay, so this we connected like this. So now what we need to do means okay, so or else we will do one thing in this only, just have this little bit above and go to DRC, check hierarchy. Okay, so why it's giving the error? So okay, so let's decrease this to 25 and go to tools, DRC. Yeah, now it is not giving error, so we can connect it like this now. Okay, go to tools. Yes, there is no any error, we can connect like this. and this one we connected like this, and this the drain. Okay, so drain of this NMOS we connected here, and these two are internally connected, and this one another uh, from this another one, these two are internally connected. Okay, from this another one we just need to connect it to the ground. So this is our ground, just have it here, and we need to connect from here to here. Okay, so go to tools, check. Okay, go to tools and check DRC, no errors. So now we need to give the inputs. Okay, so input, so one is from here. Okay, so for the input we can have this over here, and we can have one input here, and this the another input we can just have over here. Okay, so another input can just have, here. Go to tools, DRC, no errors. Okay, so these two are the inputs, and we need to connect even these inputs. So from this P1 we can cross this, like we can connect like this. So what we gave here means, in the schematic we can see this one is connected to, okay, so this one is connected to that is this drain. Okay, so this drain, this input is connected to the A, that means this NMOS. So this input is connected to this NMOS, so we can directly connect like this, and here this input is connected to this PMOS, we can directly connect like this. Okay, so now go to the tools and check DRC. Okay, there is no any errors, so this much long is not required, this much is enough. And here we need to have the via, go to the X components and go to here via, and just select this. Okay, so have this via here, it's not possible to connect like this, and similarly even have placed the via here also. So now just extend this here also, just extend this, and we need a metal, so just connect like this and just connect like this. Okay, so now you can okay, so now go to the tools, check hierarchy, so there is no any errors. So now we can just click here and create expert, and this is the A, input A. So A, and this is the input, and click OK, and this is the B, control expert, and this is the B, create input, and click OK. So this is the, okay, so I need to select this and go to create expert and create B, click OK. Why it's not taking, it's giving something. Okay, select a node first, so this has to be selected like this. Okay, I selected this, and control expert and B, click OK. It is not taking this. Okay, let's delete this and have it here. Okay, now control expert and B. Okay, so now we took, so A and the B, these two are the two inputs, there is no any errors, and we need to have export for this one, that is this is VDD, and here we need to have the power, and click OK. So this is VDD, and here control expert and G and D, and here you just click on the ground and click OK. So again it is not selected, select it properly like this, and control expert and G and D, click OK. So this ground VDD, and we need to have the set spice model for all these NMOSes. Go to spice, set spice model, and similarly you just need to, okay, so no, we need to select that. Okay, so it's selected, just have it here. And even for this PMOS, go to tools, set spice model, and for this also go to tools, simulate spice, set spice model, and for this also select this, go to tools, simulate spice, and set spice model, and bring all these just outside of this diagram, and just name it as this is NMOS, and this is PMOS, and this is NMOS, and no, this is PMOS, and this as NMOS. Okay, so now we have PMOS, NMOS, PMOS. Okay, so now we can just go to the tools and ERC and check well errors, if any errors. No, there is no any well errors also. So now we need to have the spice code. So for a time being, so I just copy the spice code from this only. You can just copy from here to the schematic to the layout. This similar. So we have the VDD D0 DC5, VA, that is VA, that is from A to 0, and pulse command, and VB dot run 300 and include cfm models.txt. Okay, so now let's control save this. Okay, so is this a earlier error or a new error? Let's check DRC, there is no any error. Go to the well, ERC, check well errors. No, there is no any errors. Now go to tools, simulation spice, and write spice deck. So here this will going to write the spice deck. Click add traces, and VA, VB, and V out. Okay, we forgot to add the V out in the layout. So here this is the V out. So from this one we need to take the V out. So just click on this and control expert and V out. So here just click as the output and click OK. So from the metal you can directly take the output, then control S, and you can simply check once the DRC, there is no any error. Tools, go to spice and write spice deck, and here go to add traces and VA, VB, and V out. So just click on OK. So now we can add the plot plane, and again add the plot plane. So just put VA here and VB here, and we can just have a zoom over this. This is the NAND gate. Let's just verify. So NAND gate 1 0. So here 1 1 means 0. Then okay, so for this one, okay, so then 0 1 means it has to be 1. So here it is 1. So in this also you need to measure the same thing, these delays. So from 1 to 1, so here it is 1 to 1, then the transition. Okay, so 1 to 1, so here A is transiting from 1 to 0. So this first case, A is transiting from 1 to 0. So you need to measure same as the schematic. Just refer to the schematic video how to measure these values. So in the same way we need to measure these values, and that's it. So the schematic, all these files will be shared. Yeah, thank you.